Yeah. Um, so what can a transformer model do? As we already seen, it can perform sentiment analysis to tell whether this um, sentence is a positive tone or a negative tone or neutral. You can do entity recognition, summarization, zero-shot classification, and many other applications. So why do I mention that? Because all these different applications that actually are some example capabilities of these large language models, but internally these large language models can be different. The first one is what we call encoder-only model, also known as the autoencoder models. So even though in general a transformer model has both encoder part and decoder part, but for a large language model, it doesn't have to have both parts. So the first one is the encoder-only model, where it has only the encoder part of the transformer. Um, the training process is a little bit different. The pre-training, I mean, pre-training use this called mask language modeling. Um, it it takes the input training, takes the training data and use the training data. It randomly masks off some of the tokens from a given input. Then the model trains itself so that it tries to produce a token that matches the real um, token in the input text. Um, of course, it may produce a wrong token at the first try, but eventually, hopefully, you'll get a right prediction of that missing token in the middle. It represents the input from two directions, both directions. Um, the the this type of model is best for text classification or semantic similarity search. What do I mean by that? Semantic similarity search, for example, if you type a search in a keyword in the search box, the search in a document, if you do a literal search, that means you only match the exact word, even case sensitive. For the semantic similarity search is that it matches the word or similar words in that document. So that's what this encoder only module is good for, what it's trained for. For decoder only, it's also called autoregressive model. It is most of the large language models, the tools that you are using, ChatGPT models and the gamma models we're using in our lab, llama models, all these are decoder only models. And they are trained using unidirectional causal language modeling. And that's why if you recall some of the APIs we call in our example code, it's called causal LM. So this is where causal LM is from. It essentially is what we typically, intuitively we can think, okay, we have this input, and we produce, we want the models to predict the next token. And that's what really this causal language modeling is for. It takes the input and looking at from the one direction up to k tokens, then we predict the next token. These type of models use millions of text samples to learn the statistical language representation. And so most of the popular LLMs are this type of decoder-only LLM. Well, of course, we can have both encoder and decoder. For this type of models, they often are called sequence-to-sequence model. They are trained slightly differently using a consecutive multi-token masking technique. the decoder attempts to reconstruct the masked sequence of the tokens. This type of language models are good for translation and text summarization tasks, and these are represented by T5 and Flan T5, this type of models. Now, with that said, if you, let's say, ask a ChatGPT to translate or do text summarization, even though ChatGPT is based on a decoder-only model, it does this type of task like decently. So really, there's no clear cut. The decoder-only model can only do, prediction or to write a new drama plot. As you already seen that, you can also do text summarization, even sentiment analysis. So it's capable of doing these tasks. As you grow the size of the model, billions of parameters, and using large number of different types of documents, it also learns these capabilities. So there's not a clear cut which type of model can only do what type of tasks.